When you set these up, you should have set up all the possible combinations between P and Q and R, then compared P to Q, and then compared that group to R. So double check yours. If you did not do them in the same order, try to go across and look for like where you had all trues and check those lines. So just if you need to check it this way. So starting on page 65, we're going to be talking section 2.3, conditionals and biconditionals, right? The first type of statement that we talk about is called a conditional statement. A conditional statement is a statement of the form if P, then Q. All right, if P, then Q. So your first thing that they want you to notice is it's written in the form if P, then Q, which is denoted. So the notation for this, the symbolic form of this, is a P with an arrow and Q. So your symbolic form there is PQ. If, then PQ. It is read if, then PQ, but it actually means that P implies Q. So in that little box off to the right there, we have an arrow. P implies Q. P implies Q there. All right? You have two parts of a conditional statement. All right? The hypothesis. The hypothesis is the phrase immediately following the word if. The hypothesis is the phrase that is immediately following the word if. All right? The conclusion is the phrase immediately following the word then. It is the conclusion. So the hypothesis immediately follows the word if. The conclusion is the phrase that immediately follows the word then. You have identifying the hypothesis and the conclusion of these statements. If you live in Nashville, then you live in Tennessee. So if I were to ask you for the hypothesis, it is the phrase immediately following the word if. So if they wanted you to write that, you don't include the word if. It is the phrase after it. So the hypothesis here is that you live in Nashville. So your hypothesis here is that you live in Nashville. And then the conclusion is the part that immediately follows the word then. So the conclusion is that if you live in Nashville, then they are going to conclude that you live in Tennessee. And so that would be your conclusion. All right, so go ahead and do number 2. Write out the hypothesis and the conclusion for number 2. What is your hypothesis? If the sum of the measure of two angles is 90 degrees, then they are complementary angles. What's your hypothesis? The hypothesis is that the sum of the measure of the two angles is 90 degrees. That statement right there is your hypothesis. So what is your conclusion? They are complementary angles, yes. You can turn a statement, just a statement that is not if-then, into an if-then statement, all right? So this says, write each statement in if-then form. There are no clouds in the sky, so it is not raining. And so if we were to convert this to an if-then statement, we would just say, if there are no clouds in the sky. And that would be our hypothesis here. If there are no clouds in the sky, then what would be our conclusion? What do you think our conclusion would be? It is not raining. Now, we are not at this point talking about truth value, right? Truth value, you just have to provide an example where you meet the hypothesis and you don't meet the conclusion. So we are going to talk about truth value, but if we were, what you're going to do is you're going to compare this hypothesis and see if you met the hypothesis. So, you have to make sure that you have a hypothesis based on your statement and a conclusion. Look at the next one. School will be canceled when a blizzard hits. School will be canceled when a blizzard hits. What do you think for this one would be your hypothesis? Doesn't have to be in the right order, but yeah, my hypothesis is going to be the blizzard piece of it, right? Because that's what's based on this sentence. So just because it gave it to me in another order, my if-then statement would actually be if a blizzard hits. That would be my hypothesis for this one. And then I would say, then school will be canceled. And so it might not always be in the same order that they gave you to make it actually make sense for the statement that they're looking at. Now look at the last one. A triangle has 3 sides. This could be actually written 2 different ways, but what's a way that would be a hypothesis and a conclusion on this? A triangle has 3 sides.
If a shape has 3 sides, then it is a triangle?
Right, so one way you could do it is you could say the if part could be the 3 sides, and the then could be the triangle, right? You could actually reverse that one. You could say if a shape is a triangle. You could say if the triangle part, and then the 3 sides part. So this one you could write multiple ways, and it would work. You could probably write the first one multiple ways too, as well. All right, so let's look at the handout. Write the following statement in if-then. An obtuse angle has a measure greater than 90 degrees. So in this case, I would say if an angle is obtuse, and you can change the words around a little to make it more grammatically correct, then the measure, it has a measure of more than 90 degrees. All right, so you can switch it around. You don't have to use the exact words. All right, but that's how you would say it. So let's try number 5 on your handout. Number 5. This says all numbers divisible by 4 are also divisible by 2. So if a number is divisible by 4, then it is divisible by 2. If a number is divisible by 4, then it is divisible by 2. Now we want to talk about truth value of conditional statements. So they've given us a truth table here. You have a couple options. You have 2 statements, P and Q. If P, then Q, all right? So this would be the truth table for it. You know you can have true, 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 false, false, true, false, false. But then let's look at what happens when we have these. How do we determine if it's true or false? What you'll notice is that if the hypothesis is true and the conclusion is true, your statement is true. If the hypothesis is true and your conclusion is false, that is false. If your hypothesis is false and your conclusion is true or false, your whole statement is true. Now, why is this? So we are saying in a hypothesis and a conclusion. If your hypothesis is never met, then you cannot tell me the statement is false because I did not meet the hypothesis to set the bar for that, okay? So let's say, for example, your parents say, if you clean your room, I will give you $100, right? Something hopefully they wouldn't actually give you for, right? And so you clean your room and they give you $100. Did they tell you the truth? Yes, all right? If you clean your room, they'll give you $100. Let's say you clean your room and they did not give you $100. Did they tell you the truth? They did not. They say the same statement. If you clean your room, I will give you $100. You don't clean your room. How do you tell if their statement was true or false? You did not meet their hypothesis. So whether they give you $100 or don't give you $100, it doesn't make their statement false because you never met the hypothesis to begin with, okay? So when you are looking at the truth value of an if-then statement, the very first thing you do is, did I meet my hypothesis? Did you clean your room? If you did, that is the only way you will be able to tell if their statement to you was true, right? Because you met the hypothesis, all right? If you never cleaned your room, you cannot say, well, you lied to me. Well, no, you didn't meet the hypothesis to garner that true or false, okay? So you have to assume the statement is true because you never met the hypothesis to begin with, all right? And that's how you do a truth table, and that's how you determine the truth of an if-then statement. So let's look at example 2 here in our books. It says, Coach Jones promises players, if you win the championship game, then I will buy you a steak dinner. Determine the truth value. A, the coach bought the team a steak dinner after they won the championship game. Was his if-then statement true? Yes. They met the hypothesis of the championship. He met the conclusion. The coach did not buy dinner after the team won the championship game. That's false. They met the hypothesis. He did not meet. Coach bought the team a steak dinner after they lost the championship. That's actually true. He didn't say, I won't give you a steak dinner, right? They never met the hypothesis here. So whether or not he buys them a steak dinner, his statement was still true. We have to assume it true because we can't prove otherwise. The coach did not buy a dinner after they lost the championship game. That's true. The statement is still true. We're looking at the if-then statement. Is his if-then statement true? If you win the championship, I'll buy you a steak dinner. He didn't buy them one because they didn't win the championship. His statement is still true, right? They didn't meet the hypothesis. They did not win the championship. So the hypothesis was not met. His original statement is still true. All right? So we start with an if-then statement, and then there are other statements based off of that statement that we can look at. Okay? The first one is called the converse. The converse of a conditional statement is obtained by reversing the hypothesis and the conclusion. So if you had if P, then Q, all right? So what you are doing is you are reversing, that is the word you're looking for your handout. You are reversing the hypothesis and the conclusion, all right? If your original statement was this notation, then your notation for the for the converse is going to be Q then P. Inverse, this is the first word on your handout. This is formed by negating the hypothesis and the conclusion. Negating the hypothesis and the conclusion. So for the inverse, you keep it in the same order, but you negate each statement, all right? Think about what the notation is for negation, and that's your notation here. The negation of P, then negation of Q. So if you negation of P, then negation of Q. That is your notation for inverse. And then the last one is the contra positive. This is formed by negating and reversing the hypothesis and the conclusion. Negating and reversing the hypothesis and the conclusion. And so your notation here is you reverse the order and you put the negation marks in front of them. Reverse the order and put the negation marks in front of them. All right? So those are three statements that you can get from the conditional. All right? Let's look at the example in your book, middle of page 67. The example in your book is in the middle of page 67. So when you are given a conditional, you want to establish what the hypothesis is, you want to establish what the conclusion is, all right? And so my hypothesis here is the measure of an angle is 135. My conclusion is the angle is obtuse, all right? The angle is obtuse. So if I wanted to do the converse, I am going to say then, if, and now I'm going to take the conclusion. The angle is obtuse. Then the measure is 135. All right. This would be the converse. That would be the converse there. All right. If I wanted to write the inverse, I am going to take these and I am just going to negate them. Okay? So the inverse, if the measure is not 135, then it is not obtuse. All right, so this is my inverse. And we're going to talk about truth of these. All right, the third one is contrapositive. So contrapositive is going to look just like the converse, but they're negated, okay? So if the angle is not obtuse, then the measure is not 135. All right, so let's talk about truth of these. Let's talk about the truth of value of the conditional statement. The first statement, if the measure of an angle is 135, then it's obtuse. Is that true or false? Is that a true or false statement? If you have a measure of an angle that's 135 degrees, it is obtuse. That's true, okay? So this guy right here is true. Now, just because he's true doesn't mean the other ones are going to be. So the next one, if the angle is obtuse, then the measure is 135. Now, all you have to do is present me with an example that meets the hypothesis, but does not meet the conclusion, okay? Just like your example with your parents. If you meet the hypothesis and the conclusion is not met, it is false, okay? So, if the angle is obtuse, then the measure is 135. Can you present me with an example where you have an angle that is obtuse, but the measure is not 135? Yes. Any angle above 90.
There's 89 of them.
Right. Yeah, pretty much. All the way up to 180. Okay. So you could say, well, here's an example, 95 degrees. Did I meet the hypothesis for that?
Yeah.
Yes, I gave you an obtuse angle. Did I meet the conclusion for that?
No.
No. This statement right here is false. That's a false statement because I just provided you an example that meets the hypothesis and does not meet the conclusion. All right, let's look at the next one. If the measure is not 135, then it is not obtuse. True or false? Why is that?
Because it means the same thing as the first one?
It doesn't mean exactly the same thing, but you're presenting with a different hypothesis. So give me an angle that is not 135 and is not obtuse. So you're reversing it. You can give me actually a different angle. You can't give me 95 here, right? Right? I mean, you could, but that would still be obtuse. So you have to meet the hypothesis. It's not 135, but it does not meet the conclusion. It's not obtuse. Give me an angle that's not 135.
If it's not 135 and it's not obtuse, then it means both of them.
But we only have to prove the hypothesis and disprove the conclusion.
No, but what you just said would be proving the conclusion.
No, it wouldn't. Not
said-
135, but is obtuse.
No,
I can give you
said
an
it
angle.
isn't obtuse.
So this one is also false. All right. If the angle is not obtuse, then the measure is not 135. Is that one true? Again, no, right? I can give you something that is not obtuse, right? Or that one is true. I can give you something that's not obtuse, but it's not going to be 135 either, right? So this one right here, I'm not thinking you can provide an example for that one, right? Because if you gave me 135, that's the only option for that conclusion. So if it's not obtuse, the measure is not 135, right? Make sense? All right, so let's look at your handout. So I want you to try this one on your handout. This one is number 1 on your handouts. If it's Saturday, then there is no school. Inverse, converse, and contrapositive. Pay attention because they flip the order. Your book order is converse, inverse, and contrapositive. But inverse, converse, and contrapositive, write the statement and then tell whether it is true or false. Tell whether it is true or false. All right, let's go over these. Inverse. Inverse is where you keep them in the same order, but you negate them. So the inverse should look like this. If it is not Saturday, then there is school. If it is not Saturday, then there is school. Is this true or false?
False.
False. What is your counter example to this?
Sunday.
Yeah, Sunday. And for this week, Monday, actually, right? So anytime you give me false, you're going to have to give me a counter example of it, right, by the way. If there is no school, then it is Saturday. So this is the converse. You just switch the order. If there is no school, then it is Saturday. This should be the same conclusion, right? This should be false. Same reasoning. You could say, well, there's no school on Sunday, which meets that, but it is not Saturday. All right, contrapositive. This is where you flip them and negate them. If there is school, then it is not Saturday. Is this one true or false? This one is true. All right, this one is true. And, all right, the definition of a biconditional statement, it's a conjunction of the form if P then Q and if Q then P. So, a biconditional statement is a conjunction of the form if P then Q and if Q then P. So it is a conjunction between the conditional and the converse, okay? This is a conjunction between the conditional and the converse, all right? The notation for a biconditional statement is P and Q with a double arrow in between it. And it is read if and only if. If and only if. For this type of statement, your truth value has to work both directions. All right? So when you have a biconditional, in order for it to work, it has to go both directions. So a biconditional statement then is true when the conditional and the converse are true. So when the conditional and the converse are true. That is when you will have a true biconditional statement. All right? When the conditional and the converse are true. All right, so look at the example then in your book, page 67. Coplanar lines do not intersect if and only if they are parallel. All right? So your first, if you were to split this up into two conditional statements, you would say if coplanar lines do not intersect, then they are parallel. So is that a true statement? Coplanar lines that don't intersect. That is actually the definition of parallel. So that statement is true. All right? And then your converse then of that would be if two lines are parallel, then they are coplanar and don't intersect. And that is also true. So this would be a true biconditional statement. All right. So you can split every biconditional into two statements. And if they're both true, then your biconditional is true. All right. So let's look at your handout. The first one here, we'll do it together. Two angles are supplementary if and only if the sum of their measure is 180 degrees. All right, so we are going to break it up into two. So what's my first statement here? Two angles are supplementary if and only if the sum of the measure is 180. So I would say this would be my hypothesis for that one. If two angles are supplementary, then what's my conclusion? Yeah, then the sum of their measures is 180. All right, so that's my first one. Then I have to write the converse here. All right, so my converse is just going to be the flip of that. If the sum of the measures of two angles is 180, then they are supplementary. All right, so then I'm going to say this one is actually true. Y'all haven't learned the word supplementary, but it means they add up to 180. So this truth value would be true. For a biconditional, if I can just disprove one of the statements, the whole thing is false. So if either one of these were not true, if I can give one example of either of those statements not being true, then I can disprove the whole biconditional. I can disprove the whole biconditional by one example of either of them not being true. All right, so go ahead and try 2 on your page. Go ahead and try 2 there. All right, let's look at this. The two conditionals would be if I wear my snow boots, then it snows. If it snows, then I wear my snow boots. True or false? And I guess this is relative. I would probably say this is false because I don't own snow boots. So if it snows, I'm not wearing snow boots. So as long as you gave an example like, no, I could wear my snow boots anytime or something, as long as you gave me a valid example as to why that would be false, I would take false here. So this one is conceptually hard to look at with just the notation. It's called the equivalent disjunction theorem. The conditional P then Q is logically equivalent to not P or Q. Not P or Q. It is equivalent, logically equivalent. So that means that if your if-then statement makes sense, then negating your hypothesis and putting the word or with your conclusion would also make sense. All right, so let's look at the example they give you. If a child disobeys, then he will be corrected. If a child disobeys, hopefully, then he will be corrected, right? And so if we negate that, if a child obeys, so we're just going to negate it. We're not going to put the if part. We're just going to write the hypothesis negated. So a child obeys, right, or disobeys. So a child disobeys. How would we write that as a statement that is negated? What's the opposite of that? Yeah, a child obeys. And we don't need the if. So a child obeys. And they said or, and we write the second half exactly the way it is. Or he will be corrected. That makes sense. And that follows the if-then statement. That follows the same logic of the if-then statement, right? So they said if a child disobeys, then he will be corrected. It is the same thing as saying the child obeys or he will be corrected, all right? And so that's just an example of how you can rewrite an if-then with a negation and a disjunction, all right? A negation and a disjunction.